Next, we're going to have John Hammond from Intel. He's based in Austin, Texas. He's been working on Lustre for 8 years, first at TAC and more recently as senior engineer at Intel. Among his many contributions to the Lustre code base was the OpenSFS funded code cleanup project. John's getting wired up here. The thing that I can say about John is a guy that I worked with said that his code reviews were probably, harsher than anything he'd ever seen, but it made for better code. So thanks for doing what you do. Ladies and gentlemen, John Hammond.
Thank you, Steve. So I want to talk today about security in Lustre, where we are, what we have, and where we're going. So I think the current story is that the security you find in Lustre reflects its roots as a HPC file system. We assume, that the deployment is maybe a single room, a single site. There's a strong degree of physical network isolation for the Lustre system, and we just trust what's going on in the room. I mean, that's where we've come from. We support traditional POSIX access controls, just like ext4, just like NFS. We trust if a client can connect, then it will connect, right? If it can route, and IP tables aren't in the way, or there's nothing like that, then we're good. We trust the user and group information that comes in the RPC. If the client kernel is intact and it's maintaining that, keeping the users honest, then the Lustre metadata and object storage servers trust that. But this is, this is fine for some uses. It may be fine for some sites, and it's not enough for others. So in the past, few years, we've been working towards having a better answer so that Lustre can be used with PII and places that require a higher assurance about security with things like SE Linux and other security mechanisms. So what's emerging? I mean, I think some of this stuff emerged a long time ago. And this is just a list. I'll go and touch on each one of these soon. So we have SE Linux, which does mandatory access controls. Ongoing Lustre development is adding node mapping. So we can classify clients by their network address, and we can remap and squash different user IDs and group IDs. We have 2 flavors of Kerberos that are working, being fixed, or being developed. We have 2 flavors of GSS. Those are Kerberos and shared secret key. And last, we have a namespace subdirectory mount that's in progress. A bit, what is security? I guess it's the property of being secure. The breakdown, I think, is usually 3 or 4 things: authentication, trusting that someone is who they say they are; authorization, whether they can do what they are asking to do; encryption, to keep secrets, and maybe part of encryption, or maybe another bullet would be integrity, to make sure that messages haven't been modified when they pass through a untrusted network or untrusted component. So we need all of these things working correctly to have a secure system, or to, there's not a secure system, there's just degrees of security, and we can strengthen each of these, I think, individually or together. SE Linux, I mean, as people have said, it's the thing you turn off, you know, when you're setting up your systems. It's a big pain, but you know, it is useful. Why is it useful? Well, I mean, in traditional Unix, you have discretionary access controls, which basically means that if I own a file, I can change its permissions to whatever I want. So I can share information with everybody. It's at my discretion. SE Linux, it is normally used to confine that information. So it takes the keys away from me, and it puts in what's mandatory access controls. So I can't change permissions on files arbitrarily. And the idea here is confinement. So if you have something like, on the one hand, if you have like an untrusted web server that's maybe exploitable, then you have these, you know, you have it jailed by mandatory access controls. Or if you think about it in terms of like multi-level security, classification levels, you can't read up and you can't write down. So you can turn on Lustre with, at least with SE Linux in the type enforcing mode, and it works. There are some limitations to how it works. The checking is done on the clients. The SE Linux contexts are not sent to the metadata target, so we're not checking there. It's not enforced on the server. If you can compromise the client, you can turn off SE Linux. This is something that's true of any system, whether or not it runs Lustre, and it's beyond our scope. You can mitigate this by using the other things we'll talk about today. You know, restricting the clients that can connect to trusted clients, auditing your clients, monitoring the configuration, making sure that only correctly configured clients are around to connect, scanning, just the normal things you should be doing anyway if you want this degree of security. SE Linux is something that you know, is required in some environments, and there are certification suites, certification tests that go along with that. You know, from where we sit at Intel HPDD, we can't see these certification tests because they're not made public, and they are in fact tied to the whole stack. So everything you install on the node, I think, gets certified together. And so since we don't do the whole stack, we just do the Lustre part of it, we're not in the certification business. We just need to do what we can so that our part of it can be part of a certified whole. So moving on from SE Linux to the UID GID mapping. The idea here is, I think, best motivated by you know, a thought experiment where you have, you know, multiple sites, maybe open science sites that want to share a file system. Well, these sites have been administered separately for tens of years, so they have. They don't have a unified password file, right? You have a user Bob at the first site that has, you know, UID 1000, and at the other site, somebody else has that UID. So since Lustre doesn't, Lustre just deals with numerical UIDs, when you try to have nodes at these two sites mounting the same file system, you know, everything looks wrong. You know, if I create a file over here, and I look at it over here, it doesn't have the right owner. You know, it can be worse than that, you know, Or maybe I have accounts at both sites, but my UIDs are different. The UID-GID mapping, which is driven by IU, allows us to create maps based on NIDs, so based on the network IDs of the clients or ranges of NIDs that say, if a client comes from this address range and they put UID 1000 on the wire, then we'll change that to 1040 when we look at it on the MDT. So if I'm, Bob here can be Bob there, and they can use the same file system even though they're totally separately administered sites. So you configure ranges of NIDs, and you say, map the IDs in this way. Something you script up, and then when they connect, the admin does the work, and the users see the benefit. We can use this not just to fix the administrative, mismatches, but we can also use it for security purposes. So we can say, we really the only valid Lustre user from this site is Bob, right? So everybody else, all the other UIDs, we'll map them, we'll squash them as we do in NFS. Or in a patch that I don't think has landed yet, we can just wholesale reject RPCs that have unrecognized UIDs. So we can really isolate traffic from a given NID or a given network to just one user or just a certain set of users. So I think this is a very good, a very strong isolation feature that we're getting. It's, I think, much stronger than what you can do with NFS right now. So the two GSS flavors, we have different, why do we have two GSS flavors? Well, I'll tell you why. I mean, we have Kerberos, which everyone knows and loves, right? And, but it turns out it doesn't work for everybody for sort of political reasons. If you're hpc.faber.edu and you want to turn on Kerberos, then you probably need permission from the guys who run faber.edu. And that's been a problem, I think, for several sites. So when they can't use Kerberos, they might look at using SSK, shared secret keys. You generate some keys, you put them on your USB sticks, you drive them around, you give them to your friends, then they plug in, they have these keys, they configure Lustre to use them, and then at the portal RPC layer, everything gets encrypted according to these keys. It's tied into, as Andreas was saying earlier, the Linux kernel's crypto routines. So, with the right CPUs, it's being offloaded to hardware. This is work in progress scheduled for the Community Edition 2.9. You can go on review.whamcloud.com and look at it as it moves in. And then just a side note, for the Cloud Edition, we have IPsec working. So this works with IP or TCP networks, but there's no IPsec over InfiniBand or the other more exotic interconnects supported by Lustre. And the last one, subdirectory mounts and file sets, which is also in progress, also coming in 2.9, allows us when at a client mount time to mount a subdirectory of the Lustre namespace instead of the whole deal. So you can just do /Lustre/ or /scratch/Bob, and then that client then from then on will just see that part of the subtree. So internally, we are just changing the FID of the root directory that the client uses from the true root FID to the FID of the selected subdirectory. And in doing so, we are taking away access to the .lustre pseudo directory, so they won't be able to do open by FID. They won't be able to do FID to path. But we're still, you know, sharing resources in the. It's not like having a separate file system on the server side. It's not necessarily a security feature, but I think when used with when it can be tied into node maps, you can tie this into node maps. I think this is in progress; it hasn't been landed, but you can say that, you know, clients that come from these NIDs, they don't see the whole Lustre file system; they just see a subpart of it. And it could be used with containers. When you pass mount points down to containers, you can just expose the subtree to the container. So that's good isolation within the client. Where am I on time, Joe? Did I just burn through this stuff? All of this stuff is being developed out in the open, developed and reviewed on the master branch of Lustre release. So we have experts from Intel and the other Lustre developing organizations reviewing, critiquing these patches. I won't say that enough eyes find all the bugs, but the more eyes we have, the more bugs we find. And we have better, you know, each reviewer brings his or her own, you know, set of use cases. And so we're getting code that's more deployable to those different use cases. The UID GID mapping and the shared secret key, both driven by IU, are being reviewed by folks from several organizations. The Kerberos and the SE Linux code are being tested by multiple vendors. And some Intel internal security folks are looking at the SSK shared key, or the shared key crypto stuff. So if you have a security person in your organization, or if you are one, then I invite you to come and review this stuff. Take a look, see what you think. As we do this big feature security stuff, we also do a lot of lower, you know, smaller, but also important work that affects the security of Lustre. So we're doing internal scans, as Peter mentioned, using, is it SMatch or SMatch? I've always, you know, when you work virtually, you just develop your own pronunciation of everything. So SMatch. We do coverity scans at HPDD, and we have other tools. These tools, they have the sets of bugs they find don't overlap as much as you think. Each one finds a different sort of set of bugs. So in the aggregate, I think we find a lot. We do both runs on each patch, and then for heavier weight analyses, we run periodically on the whole tree. We do fault injection and soak testing to make sure that we are getting the error handling correct. And I think a lot of security bugs and exploits are, the first step is to just sort of push the code out of the happy path. And then once you've done that, you go from there. And as Andreas already mentioned, by taking code away, we're making things more secure by having, simpler code, easier to understand, harder to leave exploitable bugs in. So we almost deleted as much code as we added when we went from 2.5.0 to 2.8.0. And that's a substantial number of features, but we grew by only 30,000 lines of code. So what's to do besides the work that's already been cited as in progress? This stuff needs to be integrated. I mean, some of it's fairly loosely coupled, and others, like the node mapping and shared key, I think there's definitely work that needs to be done to integrate them so that it really becomes turnkey. There's work that still needs to be done for containers to make this, yes. For both subdirectory mounts and for the GSS Flavors, if I remember correctly. SE Linux, when running the MLS mode, may need some more work. What we really need are use cases and deployment scenarios, threat models, so that we can choose and prioritize, from among the many things that we could do. Yeah, I'll just let y'all read that. And then here's legal notices. No computer system can be absolutely secure, guys. That was written by a lawyer, but it is true. Are there any questions?
Hello. Are you going moving from Kerberos to SSK?
No, these are choices.
So it will be optionally?
Yes, the user, the admin decides whether to deploy Kerberos or SSK or neither.
Are you going to solve the issue with only client-side SE Linux checks?
I don't know. I mean, it's we may not. It's it's not a small feature to check on the server side. So we'd like to know that
Sure, but it's there are only not so many test cases that we can use such SE Linux scheme.
What do you mean? There's not so many test cases for SE Linux, or to make sure that it's working as it should be, or?
Mainly, we should not trust clients.
Otherwise, older client without a Linux policy incorporated on code may read any data. Or if we move security checks on client side only, any client without Linux code inside will be read any data, because maybe connect to the servers without any special checks. Like attacker will remove all new modules and replace with older and able to connect from same ID with authentication and carriers.
But I mean, I understand what you're saying. I would say that SE Linux offers limited, even if we check SE Linux on the server side, it doesn't offer us so much, because you're talking about a compromised client, and once you compromise the client, you can just send whatever SE Linux context you want, right? And you check it on the server, and it looks fine because they sent the right thing. It's not, you've compromised the client, so you're already. So what should the server check that protects the file system from this compromised client? I mean, I'm saying that there may be a solution, but I don't think what you're proposing is adding to the security.
We have a few more minutes. Any other questions?
Thank you.
John, thanks a lot.